Hello and welcome to some online class. This is Dr. Subrat Kumar Mahanti. Friends, today we shall discuss about induced mutation. On the earth, all organisms are exposed to a plethora of agents that damage DNA and cause induced mutation. The mutation that is caused by physical agent or chemical agent is known as induced mutation, and the agents are called as mutagens. Some of the mutagens are naturally found in the environment. Remaining mutagens are man-made. The mutagens that are naturally found in the environment are fungal toxins, cosmic rays, and UV light. These are the natural mutagens. What are the artificial mutagens? Artificial mutagens is also known as man-made mutagens that include various industrial pollutants, medical X-rays, and chemicals that are present within the tobacco smoke. So now we shall discuss about various mechanisms that cause induced mutation. Some of the compounds are known as base analogues. Base analogues are the chemical compounds that are structurally similar to purine or pyrimidine. So base analog can substitute for purine or pyrimidine during nucleic acid biosynthesis. So because of insertion of base analog into the newly synthesized DNA strand during the process of replication, transition mutation can occur. One of the examples of base analog is 5-bromouracil. 5-bromouracil is a base analog. It is derived from uracil. And 5-bromouracil is a thymine analog. So 5-bromouracil can pair with adenine. 5-bromouracil also increases the sensitivity to UV light, which is itself a mutagen. 5-bromouracil it base pair with adenine, and after tautomeric shift to enol form, 5-bromouracil can also base pair with guanine. Due to the ability of the enol form of 5-bromouracil to pair with guanine, this base analog can cause transition mutation in which AT base pair is converted to GC base pair following replication. Another base analog is 2-aminopurine. 2-aminopurine is another base analog. It is an analog of adenine. So 2-aminopurine it can base pair with thiamine, and also it can base pair with cytosine. Because of the ability of 2-aminopurine to base pair with cytosine, the incorporation of this base analog during the process of replication can cause transition mutation in which AT base pair can be converted into CG base pair following replication. This is about various analogs that cause induced mutation. There are some compounds known as alkylating agents. Alkylating agents, they donate alkyl group. For example, mustard gas. Mustard gas, which was discovered during the Second World War, it donates an alkyl group to the amino or keto group in nucleotides. Mustard gas is a mutagen. It is an alkylating agent. It can add an alkyl group to the amino group or keto group of various nucleotides. For example, ethyl methanesulfonate. Ethyl methanesulfonate is a mutagen that add alkyl group to the keto groups in the number 6 position of guanine and number 4 position of thymine. So these alkylating agents causes a change in base pairing affinity. The alteration of base pairing affinity that is induced by various alkylating agents, for example mustard gas, it can induce transition mutation. For example, 6-ethyl guanine, it can base pair with thymine because 6-ethyl guanine is an analog of adenine. So this is the mechanism by which alkylating agents cause induced mutation. Another group of chemical compounds which has the shape and dimension by which they can wedge between base pair. These agents are called as intercalating agents. Intercalating agents are the chemicals that can fit between base pair. When intercalating agents are inserted between base pair, it induces structural distortions. So the intercalating agent cause structural distortion in the DNA double helix. So the structural distortions, it affect many functions including transcription, replication and repair. There are few intercalating agents which are used as DNA stain. For example, ethidium bromide. Ethidium bromide is a chemical compound that is used as DNA stain. So ethidium bromide is also another intercalating agent. Some of the drugs used for cancer chemotherapy are also intercalating agents. Example is doxorubicin. Doxorubicin, which is used for treatment of Hodgkin's lymphoma, is another intercalating agent. Similarly, dactinomycin. Dactinomycin is another intercalating agent that is used for the treatment of a variety of sarcomas. So friends, these are the mechanisms by which base analogues, various alkylating agents and intercalating agents cause induced mutation. Friends, we are discussing about induced mutation. Another group of chemical that cause mutation are known as adduct forming agents. A DNA adduct is a substance that binds covalently with the DNA and alter its conformation that interfere with DNA replication and DNA repair. Examples of adduct forming agents are acetaldehyde and heterocyclic amines. Acetaldehyde is a component of cigarette smoke, and various heterocyclic amines are produced during cooking of fish, beef and chicken. These heterocyclic amines are formed at high temperature from amino acid and creatine. Many heterocyclic amines bind covalently with guanine. At least 17 heterocyclic amines have been linked with the development of various cancers like breast cancer, stomach cancer and colon cancer. In addition to adduct forming agents, mutation can also be induced by UV light. Ultraviolet light is a part of electromagnetic spectrum. It consists of energy waves, and you know that nitrogenous base purines and pyrimidines absorb UV light intensely at 260 nanometer. One of the major effects of UV radiation on DNA is the creation of pyrimidine dimer, particularly thymine dimer, that consists of two thymine residue. The thymine dimers causes structural distortion in the DNA double helix that inhibit normal replication. As a result, errors can be introduced into the nitrogenous base during the process of replication, thereby causing mutation. In addition to UV light, mutation can also be caused by various ionizing radiations. Different types of radiations like X-ray, gamma rays and cosmic rays are more energetic than UV radiation. These radiations penetrate deep into the tissue and ionize various molecules that are present nearby. Because these radiations cause the ionization of various molecules, so they are called as ionizing radiations. As ionizing radiations penetrate into the cell, stable atoms and molecules are converted into free radicals. What is free radical? Free radicals are chemical species that contain one or more unpaired electrons. These free radicals alter purines, pyrimidines in DNA. It also breaks phosphodiester bond. These free radicals also disrupt the integrity of chromosome, and they also introduce a variety of chromosomal aberrations. So friends, this is about induced mutation and about its causes. For more updates, please subscribe my YouTube channel, Sam Online Class, and also please share your comments. Thank you very much. See you again. Bye bye.